We hear the word optimization very often, like optimizing a process, optimizing the efficiency of the workforce, or even optimizing the way healthcare is provided in a society. But the optimization we're going to learn in this course has a very grounded definition. Given some things that we can change, what's the most optimal choice that we can take while satisfying any constraints we may have that will give us the best results? So essentially, it is about systematically finding the best solution with respect to an objective and some constraints. You can see how clear and unambiguous this definition is. We need at least a metric that defines the success, some variables that we can alter, and some constraints that highlight what's acceptable and what's not. But optimization is actually something quite innate to our human nature. Even back in the ancient times, people relied on optimization principles to solve practical problems. One classic example is the story of Queen Dido's problem, which, according to legend, when Queen Dido fled to Tunis, she negotiated with a local leader to acquire as much land as could be enclosed by an ox hide. The leader, thinking it was just a small amount of land, agreed to it. But Dido had other plans. She cut the hide into thin strips, creating the longest possible string, and intuitively arranged it into a curve that would maximize the enclosed area, which is a semicircle along the seacoast. This clever use of optimization allowed her to secure enough land to found the ancient city of Carthage. Dido's ingenuity is a perfect example of how optimization has been central to problem solving long before the mathematics to formalize it even existed. Nowadays, the area where optimization thrives the most is probably the field of operational research, or OR. OR is the study of using advanced analytical methods to help make better decisions. It applies mathematical modeling, statistical analysis, and also some optimization techniques to solve complex real-world problems in areas such as logistics, transportation, manufacturing, healthcare, or even finance. But in the last decades or so, this motivation for optimization has changed and it has made its way into engineering design, especially in complex systems development, where the stakes are high and the optimal design is far from straightforward. Whether it's designing an aircraft or developing cutting-edge medical devices or creating sustainable infrastructure, optimization plays a critical role in navigating the intricate trade-offs between performance, cost, and safety. Modern engineering challenges demand solutions that are not just functional anymore, but also efficient and innovative. And optimization has become an indispensable tool for achieving these goals.